Hello all, welcome to Science Facts. In this video, we'll be discussing about thrust and pressure. Let us take an example. We wish to fix a poster on a bulletin board. To do this task, we will have to press drawing pins with a thumb. We need to apply a force on the surface area of the head of the pin. This force should be directed perpendicular to the surface area of the board. This force acts on a smaller area at the tip of the pin. So here is a picture of a bulletin board and here are the pins fixed to the board. For example, let us take the pressure exerted when there is a perpendicular force of the thumb. So let us keep the perpendicular force of the thumb as 10 Newton and let us keep the area of the pin as 2 meters square. So now as we know, pressure is equal to thrust by area or force by area. Perpendicular force is only called thrust. So thrust by area. So pressure is equal to 10 Newton, which is the thrust, by 2 meters square, which is the area. Pressure is equal to 5 Newton meter square. Now let us take the pressure exerted by the thumb when there is a non-perpendicular force. So let us keep the non-perpendicular force of the thumb as 6 Newton. It's not 10 Newton because non-perpendicular force of the thumb does not involve the whole thumb, whereas the perpendicular force of the thumb involves the whole pressure force of the thumb. So therefore now area is the same 2 meters square. So again pressure is equal to thrust by area, which is equal to 6 Newton by 2 meters square. So therefore pressure is equal to 3 Newton per meter square. So clearly we can see that the pressure over here is less than that of the perpendicular force of the thumb's pressure. This is because it does not involve the whole thumb non-perpendicular force, whereas the perpendicular force involves the force of the whole thumb. Okay, so let us take a second example. When we stand on loose sand, our feet go deep in the sand. Now if we lie down on the sand, we will not go deep in the sand. In both cases, the force exerted on the sand is the weight of our body. But why does our feet sink? We'll find out now. Explanation of what is thrust and why our feet sink in the sand and why we don't sink when we lie down. So here is the picture showing it. So basically, our whole body weight is focused in one small area, which is our foot. And when we lie down, our whole body weight is spread out throughout the whole body. You will see in this paragraph. We have learned that weight is the force acting vertically downwards. Here, the force is acting perpendicular to the surface of the earth. Of the sand, sorry. The force acting on an object perpendicular to the surface is called thrust. Please note it down. The force acting on an object perpendicular to the surface is called thrust. When we stand on loose sand, the force, that is the weight of our body, is acting on an area equal to the area of our feet. So when we stand, the whole body weight of us is acting in the area which is equal to the area of our feet. Similarly, when we lie down, the same force acts on an area equal to the contact area of our whole body. Our whole body, when we lie down, is spread out throughout the surface area. So therefore, the pressure will be less. Thus, the effects of forces of the same magnitude on different areas are different. Observation. From this, we can observe that therefore, the effect of thrust depends on the area on which it acts. The effect of thrust on sand is larger while standing than while lying down. Because pressure is inversely proportional to area. Inversely proportional means if pressure is more, then the area should be less, and if the pressure is less, then the area should be more. So when we compare it to this picture, when we are in a smaller area, the effect of force is high, and when there is in a larger area, the effect of small force is very low. The thrust on unit area is called pressure. Thus, pressure is equal to thrust by area. Remember, thrust is also force, but it's a perpendicular force. Let us solve a numerical. A block of wood is kept on a tabletop. The mass of the wooden block is 5 kg and its dimensions are 40 cm into 20 cm into 10 cm. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the table with its sides of dimensions part A 20 cm into 10 cm and part B 40 cm into 20 cm. So basically in this question we need to find the pressure exerted by the wooden block if it's made to lie on different dimensions. This is the part A, which is 20 cm into 10 cm, and part B 40 cm into 20 cm. So they've given the mass of the wooden block, which is 5 kg. Solution: the dimensions of the wooden block is equal to 40 cm into 20 cm into 10 cm. They've given it in the question over here. Here, the weight of the wooden block applies a thrust on the tabletop. That is, F is equal to mg. So basically, force is also weight. So we need to just replace F with W. Force, which is calculated by Newton, is equal to 5 kg into 9.8 meter per second square. Ms over here is 5 kg, and we know that the acceleration due to gravity on Earth is 9.8 meter per second square. So therefore, 5 kg into 9.8 meter per second square is 49 Newton. So therefore, the force is equal to 49 Newton. Area of a side is equal to length into breadth. We all know that area of a side is equal to length into breadth. So therefore, the length of the first one is, they have given dimensions as 20 cm and 10 cm. Those are only the length and the breadth. So length into breadth is equal, which is 20 cm into 10 cm equal to 200 centimeter square. Note that centimeter square is not the SI unit of area, so therefore it should be converted into meter square. So therefore centimeter square into meter square becomes 0.02 meter square. So pressure is equal to thrust by area or force by area. Force is 49 Newton and the area is 0.02 meter square. So therefore pressure is equal to 2450 Newton meter square. 49 by 0.02 is 2450, and when we include the symbol for force and area, we get Newton per meter square. When the block lies, part B, when the block lies on its side of dimension 40 cm into 20 cm, it exerts the same thrust as the force, only depends on the mass, which is denoted by small m, and acceleration due to gravity, which is denoted by small g. Again, we know area is equal to length into breadth. So basically, the force or the thrust is the same because it depends on the mass and only the dimensions are changing in this question, part B, but the force and the acceleration due to gravity remains the same, whether the dimensions change or not. So therefore, the thrust will be the same, which is 49 Newton. Now I need to calculate the area. They've given the area as 40 cm into 20 cm, which is like the length into breadth. So this length into breadth is 40 cm into 20 cm, which is equal to 800 centimeter square, which is equal to 0.08 meter square. Similarly, centimeter square is again not the SI unit of area, and therefore it should be converted into meter square. Now pressure is equal to thrust or force by area. Thrust is 49 Newton and the area we just calculated is 0.08 meter square. 49 divided by 0.08 is 612.5, and when we include the SI unit of pressure and area, we get Newton per meter square. So therefore it's 612.5 Newton per meter square. Observation. The pressure exerted by the side 20 centimeter into 10 centimeter is 2450 Newton per meter square. We just calculate it over here. 2450 Newton per meter square. And by the side 40 centimeter into 20 centimeter is 612.5 Newton per meter square. We have calculated that over here. What is the conclusion of this whole session? Thus, the same force acting on a smaller area exerts a larger pressure and a smaller pressure on a larger area. So, as we saw, pressure is inversely proportional to area. So, there will be a larger pressure in small area and smaller pressure on a larger area. This is the reason why a nail has a pointed tip. Only if the nail has a pointed tip, the area will be less and therefore the pressure will be lot, and then it can go through any wall or anything. Knives have sharp edges, so if we need to cut vegetables or fruits, it has to be sharp so that the pressure is concentrated in an area and the area is less and the pressure is more, and therefore then only it will cut those things. When buildings have wide foundations, we know that buildings have the force of buildings is a lot. Now we know that buildings have wide foundations. Basically, the weight of the buildings is a lot, and they need to be built wide so that the force is spread over a larger area, and which results in the pressure being less, so that the building does not collapse. Hence, we conclude the session with this. Don't forget to like, share, and subscribe. Thank you once again.